And then we are almost done with monthly zero rate, but we starting from the 0.25 year 3 months. So the initial first month, the second month, we have to think of slightly. In extrapolating that one, basically we want to extrapolate from 3 to 4 months the relationship between third to fourth month and extrapolate into the 0 to 1 first and second months. So we will do very small regression. So what we are gonna do is, okay, let me delete this one. And then x2 is np, let me check first, np array. And then the first one is, okay, the third month, so x1, the third month, 2, x1, third month. This, okay, so it is third month and fourth month. That's fine. So let me take it. Let's look at the S2. And then Y is zero rate corresponding to that period. So, well, MP array and then month 0, second, okay, third and fourth month. Okay, third and fourth month is that one. And then this is Y. Okay, and then we want to find the relationship between month and the yield using polynomial function, basically linear function in our case. So Z equal NP poly fit, okay, polynomial fit, and then X2 fit Y, and then with linear function first order, okay, and then let's play a Z. Okay, so like this, and then let's express this as a function. So NP poly 1D Z is, okay, so basically relationship is like this one. Okay, so first one is the coefficient, second one is the intercept, I think, right? First one is the coefficient, second one is the intercept, and let's call this one as P. Okay, function. And then month zero rate 0 is, of course, we can plug P and we can plug x1 0. Okay, plug that one to find the relationship. So compute 1/1 month year zero rate, spot rate. Okay, and then is the second one. This is 1. Okay, okay, and then let's print month zero rate, and then we have a zero rate like this. So for the next 7 years, the monthly zero rate looks like this one. Okay, good. And then let me delete this one. And then we have interest rate. And then because we want to predict the future interest rate in the risk neutral world. So well, it is a lot of concept, but okay, basically we have yield curve. And then we want from the spot rate, we want to compute some future rate, something called forward rate, redraw yield curve on forward rate. Forward rate. Okay. And then forward rate is first month zero rate. Okay, this is the initial one. So let's fill the first one in the forward rate. For the initial rate, the very first rate, forward rate and then spot rate is the same. So this is forward rate for the same one. It is the same, but from next month it is different. Now we have to make a time. So time is basically, well, we have a time step. So NP array, okay, and then we have like I for I in range time step. Okay, so from 0 to 84 months. Okay, so it should start from I plus 1. So first month and 84 months. And then of course we want to transform it into in terms of year. It is in terms of months. So in terms of year, so multiply dt. Then we have something in terms of year. So it ends with 7. So let's call that this is the time index. Temp index, take index, time index. So index of the each one. So, and then for I in range, now we start from 1. Okay. Okay. Time, we have time step -1 because we know the very first one. Oh, sorry, very first one. And then forward rate is basically, forward rate is basically, we have to append to the previous forward rate. And the forward rate is basically weighted average longer rate minus shorter rate and then divided by dt. Okay. And then we have to divide the longer rate and shorter rate. And the longer rate is basically up to I plus 1 month 0 rate, I plus 1, and then multiplied by temp index I plus 1. And then short rate is this one. Okay. And then forward rate is basically longer rate is weighted average of a short rate and then forward rate. Okay. Multiplied. Let me check. This looks correct. This looks correct. I think this is correct. So let me see the forward rate. Forward rate is now looks like this one. Oops. So this is a list. So I have to make array numpy array forward rate and then forward rate. Okay, forward rate looks like this one. Okay, so we are done with the forward rate. With this forward rate now, okay, now we are ready to draw stock tree. Generate stock tree. Stock tree, movement of stock. So in stock tree, when we draw stock tree, we have to model up move and down move, and then risk neutral probability. Okay, so here, okay, so risk neutral probability P is basically e to the power of, okay, notation is complicated, so let's simply call R minus D and then U minus D. Okay, looks like this one as a risk neutral probability. And then here, I have to define RUT. First R equals basically this is the, well, this is the, there is well, some theory about this one, but let me just skip. This is a very deep theory about this one, but let me skip. Forward rate minus dividend yield. Dividend yield, okay. Dividend yield, and then basically multiplied by dt. Okay, so looks like this one. Ah, this looks a bit nasty, so let me make it prettier. EXP, okay, something like this. Forward rate, forward rate, forward rate. Okay, forward rate and dividend dt. Okay, and then UT. Well, I'm not gonna explain here because it is covered in the same, in the other class about theory part. This is Python implementation, so I'll skip the theoretical part, but it is very important to understand why this is the why risk neutral probability. It is very important to why risk neutral probability looks like this one, and why the R part looks like this, and why U and D looks like this one I'm about to write. This is very important, but I'm gonna skip here. So E is basically sigma, and then is given like this one. Okay. Again, and there is deep theory about this one, why it should be look like this one. And then D is basically 1 over U. Okay. For the timing, you just accept as it is. Okay. Please check other material to understand why it looks like this. So let me just implement over here. So U here and PXP, and then volatility is a sigma multiplied by dt square root. Okay, and D is 1 over U. And then let's check print U D. Yeah, so this is size of up movement and the size of down movement. Okay. And then we have to define P. P is basically, we can simply write down that one. So NP, EXP, forward rate minus dividend yield. Multiplied by dt. Okay, dividend yield multiplied by dt. And then we have to subtract d and then divide by u over d. And if we check the p, forward invalid syntax d1 over u, forward rate dividend rate dt, and then sorry. Okay, so P, it looks like this because we have price change over time because of forward rate change over time. Okay, so P looks like this one. And then let's do the stock tree. Stock tree is basically MP zeros. Okay, and then time step plus 1 because we start from 0. So time step plus 1. Okay, this is structure, but the very first one is stock tree starts from the current stock price. So stock tree starting is the stock price. And then we are gonna make it a binomial tree. Okay, so first let me print stock tree to 5 to 5. Okay, so 1 0 0 0. Okay, because I filled everything is 0 and then very first one is 1 and because of current stock price 1. Okay, so it is no wonder. Let me tabulate this one. Okay, and then so this is going up, this is going down. So let's first fill this diagonal. Let's fill diagonal term which is going down. So diagonal term is for I in range time step. Okay, and then stock tree I plus 1 diagonal movement is stock tree I and then going down. Okay, so going down. Okay, good. So to compare, let me say print U and D. Okay, so going down is this one. So this number is the same to this number. Okay, fine. And then this is going up from 1 to this is going up, going up. So this is going up from this one. Okay, so this number is going up from this one. So we move from diagonal and keep multiplying on movement to the direction of the row. Okay, okay, so now J, second subscript for J in, now it should start from I, right? I, and then to the end of time step, and then stock tree, I, okay, when it is I, but now it should be from J plus 1, okay, because it is next one, is the previous one, okay, previous one in the same row, so this one multiplied by U, and then if we do this one, okay, now, okay, this is on movement, so looks fine. Okay, let's increase a bit, 15, 15. Okay, so we have a big tree. Okay, so looks okay. Looks okay. Okay, good. So we just finished the stock tree. And then next we will draw option tree.